All right, guys. Hi. So, what can I do for you guys tonight? What can I help out in? It's homework, studying, or really anything.
Help me out with the thing that I was messaging you about earlier about the permutation and the combination for number one.
Permutation versus combinations.
Yeah, whether it's used permutation or combination of plus permutation.
Is it wait? So is it like when to use them essentially? Just to double check, like
Yeah,
when.
number one. These two.
Wait, say that one more time.
Yeah, it was for number one. I'm messaging for number one.
Yeah. So okay. So it was just basically kind of asking, if I remember correctly, just like the difference between combinations with repetitions and permutations or something like that, if I remember correctly. Um, with repetitions. So combination, permutations with repetitions, versus combinations with repetitions. We use this usually depends on whether or not we have indistinct items or distinct items. Because in both scenarios, we should be able to tell difference between our categories. Does that make sense? Or like not really?
Yeah, yeah.
Okay, like with permutations, with repetition, we're really deal we're dealing with kind of dealing with indistinct items being tossed into distinct categories. Does that make sense? That's when that's when we should be using this. This is given by n to the r usually. N to the r usually is the number of ways we can perform such an operation. Does that make sense? Where I believe n is the number of, I want to say it's the number of items, and R is the number of categories. I want to say it's that. Does that make sense? Or not really?
That makes sense.
Yep. So, for like an example, usually imagine we have to read this, kind of again rearrange the letters in the word teat, like how many ways exist, right? So here here order matters because every different variation every different variation makes a different string. Does it make sense? Or not really?
Yes.
And so every order variation makes a different string. So this is a sign of permutation, and we have repetition because there are multiple e's and multiple t's that we need to take care of. Does that make sense? So far, so good on that. Cool. C. And so I think TLDR is there are, I think off the top of my head, 5 factorial divided by 2 factorial times 2 factorial ways to do this. Something along those lines. I'll have to double check it though. But off the top of my head, this is when we are talking about permutations with repetitions. It's indistinct items being tossed into uh in indistinct categories. Shouldn't the back yeah. There well mm, it's not 3 factorial times 2 factorial. It would be 2 factorial times 2 factorial
Mhm.
times 1 factorial. The what was missing was a 1 factorial. But 1 factorial doesn't really impact anything, so. Yeah, 2 T's, 2 E's, and an H. But you can't really mess up the H, so we don't include them. Make sense? Whereas combinations with repetition, obviously that one's the other one. We're dealing with distinct, or I did this backwards. Distinct items being tossed into distinct categories. I'm messing this up. This is with combinations with repetition. We're dealing with indistinct items being tossed into distinct categories. There we go. Now I got it. This is given by the formula. Off the top of my head, I believe it's n plus r minus 1. Choose r minus 1, which is the same thing as, I want to say n plus r minus 1, choose n. Where n is the number of distinct or indistinct item, or yeah, distinct items, and r is the number of distinct categories. Does that make sense? So far, so good. Often this is called stars and bars. Yeah, I like lo-fi, man. This is just the vibe. Just nice and peaceful for me. So again, as an example, suppose I have to distribute 4 chocolate chip cookies amongst 7 people, 7 distinct people. How many ways can I do that? Make sense? Yeah, without a note, you can't give someone a decimal of a cookie or a fraction of a cookie. Does that make sense? You gotta give them a cookie or just don't give them a cookie. Either give them a cookie, or don't. Does that make sense? So far, so good. Not necessarily. That doesn't mean 1 or 0. Note that I don't say how much each person can get. It's just that whatever amount it is, it better not be a decimal. Does that make sense? So like here, I never said someone had they can only get 1 cookie. Someone could get like 2 or 3 cookies. Because, favoritism and all that stuff. Makes sense? So the reason this is combination with repetition is because we don't care. We don't care who gets the cookies. That's irrelevant to us. We just care about the distribution. Sense? That's literally all that I care about. So that's a sign that we are giving cookies that this is a combination, since order doesn't matter. So hence, order does not matter. How does this differ from normal combination? In normal combination, we're not telling how many cookies each. It's assumed that each cookie is a given, like we don't know how many cookies each person gets. Like in normal combinations, we can't account for the following situation. Like person one gets all 4 cookies. That's not counted. That's not accounted for. There's no way you could count that with a normal combination formula. More or less, yeah. Yeah. Because if we do, most people would usually jump to the conclusion that it's 7 choose 4. Well, that only describes which 4 people will get the cookies. How does the distribution work then? Distribution work after that. Does that make sense? So like I could say that the first 4 people get cookies, but they never specified how the cookies are being distributed, and so on and so forth. Yeah, sort of, according using the formula, above, we would get we would end up getting 7 plus 4 minus 1, choose 7, which is 10 choose 7. So whatever this spits out. Because there's 7 cookies or 4 cookies, so 4 plus 7 minus 1, choose oh shit, I did this as backwards. Oops. 4 plus 7 minus 1, choose 4. So 10 choose 4, sorry. 4 plus 7 minus 1, choose how many cookies? So 4 cookies. Which gives us our place. That would be and choose 4 instead of all of it. Choose 4. Does that make sense? And yeah, that's basically how I would describe combinations with repetition versus permutations with repetitions, raised to the best of my abilities, being put on the spot. That is, at the very least, how I would explain it. Any other questions you guys have for me, whether it's homework or anything stuff? Yeah, I can talk about it. So and also, so if you're able to say for number 1 permutation or combination plus repetition, you told me order in number 1, order shouldn't matter. I should have corrected myself if that was the case. Order shouldn't matter because it's an equation. It's an equation. So like, what's the difference between 1 plus 2 and 1 plus 3? There's no difference between this, right? So like, no difference between the shift of what values they are. It's the same use of values. Oh yeah, x1, well x1, x2, and x3, these are what are all categories. Those are your categories. The shift of the values mattered. Well, I mean, if we're saying that x1 plus x2 plus x3 equals 6, what's the difference between 1, 2, 3 and 3, 2, 1? I guess, is there a difference between that? Okay, I mean, the x values have different numbers, but does it? Hmm. Let's see here. How do I want to find this? So here's the question. I want to say, well, I don't know if I this. Really non-negative integers, solutions are there. So I guess like these are like I guess, unique solutions, but the numbers, but because it's really like stupid. The numbers themselves are the same combinations. Like that's kind of like the thing. It's like they're unique solutions, I guess. If you want to count it as like x1 being one is not the same thing as x1 being three. Like you can argue, like you could argue both, I guess. Like x1 is not three, it's not the same thing as one. Yeah, I would really say like 1, 2, 3 is technically the same as 3, 2, 1 because in the grand scheme of things, in the grand scheme, like what does it matter? What does it matter if like x1 is 1 or 3, right? Like that's not like what we're caring about, I guess. It's more about if it equals 6, more or less. Yeah, it's like all possibilities. I would say, I guess a better frame of mind is like you have 6 cookies and you're trying to distribute it amongst like 3 different people. That's a better way to kind of frame it. So like if you can answer that, then that's a better way to frame it. That's how I. Um, okay. Mm, Yeah, no problem. Again, sorry for the confusion. Warning sucks with this, so I do apologize. But at least that's how I would interpret it. It's just what I would say combinations with repetition is the way to go with this. Yeah, that's at least my mindset. Okay. Floyd, what was your question about number 3? What am I what's getting you stuck on uh numero tres? What would be a relation of A? Okay. So, um, how do I explain this? Basically, he's not clear about this. What you need to perform, form a Cartesian product between A and A, or in other words, what does A plus A turn into? Like what would that be essentially? So let's figure that out. So do you know how to do Cartesian product by any chance? It's okay if you don't. What's all possibilities? Like, what's an example of a possibility of set A? What do I consider a possibility? Empty sets, x comma y. Uh, well, Cartesian product is a set. But more specifically, remember Cartesian products is a set of ordered pairs, essentially. Does that make sense? Of ordered pairs, where the first, uh, eh, um, but there's a couple of restrictions on this. Couple of restrictions. If we have to do something like A cross B, let's say A cross B, then your x coordinate comes from set A, and your y coordinate comes from set B. Does that make sense? So try applying this definition. What does the Cartesian product look like? I do A cos A. Like, what's an example of an ordered pair that I could make using set A as my X and my Y? WZ, anything else? Yeah, so on and so forth. Yeah, the TLDR is there are 16 pairs in total. Yeah, there should be 16 pairs. I'll write out a couple of them. There would be WZ, WX, WY, W, W, and then one more ZZ, and like so on. Does that make sense so far? So, so far so good on how we get all these pairs. Yeah, it's 2 to the n squared. The number of relations we can form is 2 to the power of n squared, where n is the size of the set that we use. So what's the size of our set? Yeah, 4. So we can make 2 to the 4 squared, or really 2 to the 16 total relations. Does that make sense? The idea is that an example of one of these relations, like just to help you visualize this, one of them could be the set containing WX. Simple. Literally, the criteria for a relation is that it must be a subset of that Cartesian product. Cartesian product determined over here. Or in other words, for any relation R has to be a subset of A cross A. How do you get the 2 to the n squared for the total number of relations? Well, let's think about it for a second. So let's imagine let's explain that 2 to the 16th. Let's imagine we don't have that formula. Okay. So remind me how many pairs there are. Nope. Not 2. How many pairs there are in A cross A? Yeah, there's 16. Yeah, there's 16. There's 16 of them. Make sense? So now imagine, I'm going to want you to imagine that each like pair is a different piece of candy. Okay. And a relation acts like a bag. Okay. Your goal is to come up with different combinations for the bag. Make sense? So in this analogy, you're basically going trick-or-treating and you're putting different pieces of candy in your bag. And I just want to know how many different combinations we can make for the bag. Does that make sense? So far? So now let's take one piece of like candy, say, I don't know, let's say WW. Okay. With respect to the bag, what are my options? What are my options for this piece of candy? Like just from a logical perspective, what are my options? Like what can if I have a piece, so if I kind of like drew this out. So if I drew this out, so here's like here's like a candy bar. Ignore my beautiful drawing skills. So here's the bag. What can I do? What can I do with this bag? With the candy? Like what are my options to put the candy? Uh what are my options for the candy? What can I do with this piece of candy? Yeah, you can add it. What else? What's another option we could do? Exactly. Don't add it. Does that make sense? Those literally are the only two options we can do is put it in the bag or don't put it in the bag. Does that make sense? Or kind of like how the visuals work? Yeah. So if so my options is add it or add it to the relation or don't add it to the relation. Does that make sense? Now, what about a different piece of candy? Say XX. Same two options, right? Yeah, same two options. Do these do these options change for any of the 16 pairs? No. So now I have 16 twos running around. So now there's 16 twos that I have. What do I do with them? What should I do with these 16 twos? Yeah, we multiply them. Mhm. We multiply them because the outcome of one piece of candy, and I'll put this up here, but the outcome of one piece of candy should not impact the outcome of another piece of candy. Does that make sense? Because they're independent events, that's what we call them. The product rule dictates we multiply. The product rule dictates we multiply. So what is our total then? If I multiply 2 16 times, what do I end up getting? And isn't that the same answer that we got up top? Hence how we get 2 to the 16 total relations. Makes more sense? When are they not independent events? If the outcome of one event directly impacts the outcome of the second event, then they're not independent. So as an example, not sleeping and being able to not sleeping and what do I want to say is actually driving to school and parking. Like if you drive to school, that does impact how you park, because I mean kind of have to park your car. The only way you can park your car is if you drove your car in the first place. Does that make sense? Any other questions you guys have for me? So one relation would be choices I'll put in. And in terms of the question, we need to find symmetric relations with x, y. Yeah, so like these are this is all the relations like we can possibly make. Now figure out which of them are symmetric, and then from there figure out which of them have xy. That's my hint. So step one is to figure out how many of those relations we made is symmetric, and then from there figure out which of the symmetric relations have xy. CCC. Do you manually write them out and find out which are symmetric? No, do not write them manually out. For reference, that is how many relations you would have to write out. I do not recommend trying that. Not unless you want to escape this class with your sanity. Gonna have to be a little more creative than that. For extra credit, to be determined. Let's put a to be determined. How about that? Did you go over some of the questions in the question reviews you gave out? Sure. I haven't like finished my thing, but I probably can talk about some of the answers. Which ones do you want me to look at? Which questions do you want me to kind of like talk about? Whichever one. How about this? Start with one. Okay, sure. So you have strings of length 10, and they are formed from English letters. Note that there are 26 English letters. I want to know how many of them do not have the same letter appearing consecutively. And leave your answers in factorials, combinations, products, exponents. Basically, just don't try to calculate it. Okay, so how many spots do we have to fill? So let's kind of like start with that. How many spots do we have to fill? We have 25 spots. Is that how long our string is? How long is our string? Yeah, there's 10 spots that we've got to fill, right? So let's draw them out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many options does the first one have? It has 26 factorial options. That's quite a bit. Quite a bit. Yeah, just 26. Okay. What about the second one? Yep, 5. What about the third one? Not 24. Nope. It ain't 24. Remember, do not have the same letter. Yeah, it's still 25. This is because while we remove one letter, we add back the letter we used previously. Does that make sense? Take care for it. Does that make sense? So now we know that that's the second one. What about the third one? It's still 25. Does this ever change? No. It stays 25 for the rest of eternity. So we have 126, we have a 26. And how many 25s do we have? Nope. Not 6. How many 25s would we ever have in this? Yeah, 9/25s. Now the question is, no worries. Now what do we do with these numbers? What to do with these numbers? Combination? Nope. Nope. It wouldn't even be a combination because order kind of matters. Every different variation of a string is a different string. The only question we need to ask ourselves is just what do we do with these, with the 26 and the 9/25s? What do we do with them? 26 factorial and 25 factorial times 9. How did we get the factorials? I'm kind of confused on the factorial part. Because there wouldn't technically be any, there's no factorial behavior here. If there was a factorial behavior, then we would be having repeat letters. Like, if there was a factorial, then this should have been 24, 23, and so on. So, I mean, like, the question is, what do we do with this 26 and 25s? What operation do we perform? Like, in other words, what operation do we perform? Yeah, we just multiply. Simple as that. We multiply because they're independent events. So our total is just literally 26 plus 25 to the 9. That is how many strings we can make. This is what we want. Any questions on how I made this thing here? When do we use factorials? Factorials factorials is mainly when options cannot be used again. So like, so for example, if I wanted to build a string of length 10 where the same letter cannot appear twice, of length 26 using the English alphabet, it would be 26 factorial. Does that make sense? This is because no letter could ever be used twice. Since we can't repeat letters. So once we use, for example, E, it goes away. Does that make sense? Any other questions you guys want me to try? Is there any other questions that you guys kind of want me to try? Whether it's a counting question, induction question, relation question, matrices. I'll try my best, but just need to know which kinds of questions you guys want to see me attempt to try. For number 3, um, after define the total number of relations, find the number of relations that are symmetric. Yeah, find the number of relations that are symmetric. So not all of these relations are going to be symmetric. You need to figure out how many of them are symmetric. As a hint, I would draw a 4x4 grid. kind of like this. So as an example, don't save. So I would draw a 4x4 grid, sort of something like this. 1, 2, 3, 4. 1, 2, 3, 4. And then what you would have is W, X, Y, Z, and then W, X, Y, Z. Does that make sense? And what you want to do is wherever there is a coordinate to coordinate that has identical values, meaning the X and Y coordinate is the same, put a check mark. Does that make sense? So again, going back to this visual, where would where in this box here, in this box that I'm hovering over, what do I put here? Well, we'll get to the symmetric part later, but like for now, like just kind of like remember we want to put it, whenever the coordinate has identical values, I want you to put like a check mark, like a little check mark, right? So like here, what would this coordinate be? Yeah, it's a check mark because it's WW, right? Here, this is WX, X, right? So he doesn't get a check mark. Does this make sense? So find out where the check marks lie, and then for everyone, for the other coordinates, I want we discard every coordinates that have the same. Don't discard them. They're still very important. We're just going to like classify them. This is a classification system that we're kind of doing. Does it make sense? So once we have this, right? What I want you to do is for the other coordinates, I want you to take the original coordinate, then invert them. Locate the inverted point on the grid and draw a double arrow, which is a by implication arrow. By implication arrow, that being this thing here between the points. So as an example, to show you what I mean, this here is WX, right? Is he an identical pair? Good. So what we're going to do is we're going to start to draw, we're going to need to invert his point. So where is his point? What is the inversion of WX? XW, right? XW is located right here. So I'll kind of mark it with red, right? Now, what we're going to do is we're going to draw a by implication arrow between the two of them to signify that they are connected. Does that make sense? Yeah. What you're going to do is simply count how many by implications arrows you draw or you have, and how many check marks you have. Use that to start you off. Okay. Yeah, I gotcha. Any other questions you guys have for me? Any other questions that you guys want me to try to do, whether they're counting questions or anything like that? Ooh, and I'll just guess that's pretty much all I've got. Yeah, no worries. Just let me know if you guys have any other question. Just feel free to message me. I'm always down to help. Yeah. What about number two? Sure. Yeah. What about two? What's confusing? Okay. Yeah. So we break it into two parts. Combinations for repetitions and permutations without rep. Okay. Why those two are the one that work? Yeah. So there's you're correct. There's a permutations without repetition part, and then a combinations with repetition. So let's explain both of them at the same time. So for the permutations without repetition, let's look at the packets. So let's look at the packets. Now, how many are there? Yeah, there's 12. Now, true or false, they are all distinct from each other. True. Yeah, this is true. So every variation of sending the packet out, sending the packets, or every arrangement of sending the packets is unique. Does that make sense? So for example, sending packet 1 is different from packet 12, sending packet 12 first. Does that make sense? Okay, so if that's the case, if that's the case, order matters, right? What does that signify? Permutation. Yeah, a permutation. Does that make sense? So you have to figure out how many ways you can permute the 12 packets. Does that make sense? So that's the permutation without repetition. For combinations with repetition, well, let's talk about it. Let's let's look at the spaces. How many are there? Mhm. Yeah, there's 45. Now, true or false? True or false? These spaces are all distinct. Yeah, it's false, right? False. They're all the same, right? They're all the same. Now, note now we have to distribute these, well, we have to send these 45 spaces somehow, right? Would you agree that in this message, you gotta somehow send these 45 spaces? Well, well, where do spaces go? Uh, yeah, it goes between the packets, right? Now, what are the criterias? What is the criteria or the conditions for this problem? Well, not necessarily. What's the condition about spaces? With the relationship between the packets and the spaces? Yeah, 3 between each packet, right? So between any pair of packets you can think of, any pair of packets, there must reside at least 3 blank spaces. Does that make sense? Yeah, 11, there's 11 gaps, each of which needs 3 at minimum. So, at bare minimum, how many spaces are used up? To satisfy us. Like the absolute bare minimum. Yeah, it's 33. Exactly. But we need the 45. So that's the question. It's like, okay, so how many are we left with? We're left with 12, right? Do we care? Do we care where these 12 go? No. As long as they're between spaces, right? Between packets. So you have to distribute 12 identical or spaces into 11 distinct gaps. What does this sound like to you? It's a combination, yeah, that's part of it. But but notice we didn't also specify how many spaces go into a gap, right? We also have to take that into account, right? Like how many they get, right? So it's not just a combination, it's a special type of combination. What does it also have? So that's what an R. Yeah. It's not that it could be that so for example, in addition to the 3 spaces we already put, gap 1 can get all 12 remaining, all 12 remaining spaces. Does that make sense? That's an example that we could include. So we need to calculate how many ways we can do that. Exactly, because it's repetition. If it's non-repetitive, yeah, we wouldn't do that. Because we would know automatically from the problem how many each person gets. But here, since we don't know, we got to take that into consideration. Does that make sense? So far, so good. So non-repeat, yeah, or per person, and stuff like that. Like it should be known in advance. So now notice we talked about 2 events, right? The order, of the packets, and order of the spaces, right? Or and distribution of the spaces. Would you agree that these are the 2 events that we talked about? One of which is dealt with permutation without repetition. That would be ordering of the packets. And then obviously combination with repetition deals with distributing the spaces. Does that make sense so far? Now, if we have these 2 events, let me ask you this. Does order of the packets impact how we distribute the spaces? Does it impact the outcome? Is more like I want to ask of how we. I think yes, but I don't know why. Let's think about this for a second. So if we're saying that the order impacts the spaces, that would mean we would have more restrictions, right? That would mean we have more restrictions. For example, suppose I say that I sent packet one and packet one first, then I want to send like packet two next. If we have four spaces between one and two, we can still have four spaces between two to one. Well, but was that impacted by choosing to have 1, 2, and 2, 1? Or is that impacted by your choice to put the spaces there in the first place? Yeah. So so the answer to this is really not really, not unless there's not unless black magic is at play, which there isn't. Because the idea is no matter what packets I send, you're still going to have the restriction that every pair of packets must have at least 3 blank spaces. Like that restriction doesn't just go away. Does that make sense? Yeah. So if these events are independent, what do we do? Yeah, because they are independent, we do multiply. Adding is when two events are mutually exclusive. That means the outcome means two events that you're dealing with cannot be happening simultaneously. As an example, as an example, uh, fishing and not fishing. These are polar opposite events. Does this make sense? Yep. So because they're independent, we multiply. If they were mutually exclusive, meaning they couldn't happen at the same time, I would have said to add. But they are independent, so we multiply. So now all you have to do is figure out how many ways we can reorder the packets and how many ways we can distribute the 12 identical spaces into 11 gaps. So you do that, simply multiply, and the answer will stare at you straight in the face. Yeah, of course. Any other questions you guys have for me? Whether it's more questions, concept questions, or anything like that. Yes. Yeah, I'm going to do that as well. I also want to double check what the remaining stuff. For number three, how did we get 6 super pairs? Well, if you look at it, uh, so you have, so let's see here. So how many, for that, let's just assume I don't have to draw. How many coordinates have identical pairs of values? Meaning their x and y are the same. So 4. So that leaves us with how many pairs? Yeah, 12 pairs where the um where the coordinates do not have identical values. My brain is so swimming. Yeah. So here, so now notice we are dealing with symmetrical relations, right? Would you agree that we are trying to tackle something about a symmetrical relation or some shit like that in the third question? So what does that mean? Like, what does it mean if I say asymmetrical relation? Yeah. So if we have like x, y, then we need to have yx. Does that make sense? I want you to notice something. Notice these two coordinates have a dependency on each other. One cannot be present without the other. Does that make sense? Like if you decide to have xy, you better have yx. And if you decide to have yx, you gotta have xy. Either you include either both of them are there or they're both not there. Does that make sense? Because so because because they have a dependency on each other, let's merge them. Let's merge them into a what I term a super pair. So I'll give you it. So I will tell you that one super pair present here is the super pair xy, comma y, comma x. Does that make sense? So far, so good on that. Now, how many coordinates are left? It's are left where they do not have identical values. Mhm. There's 10 of them. You're left with 10 of them. So how many how many super pairs can I make with these 10 coordinates? Five. So then how many in total? How many super pairs would that total do? Exactly. 6 super pairs, which is where I get 6 super pairs. How did we go from 5 to 6? We went from 5 to 6 because of this additional super pair that I gave as an example. One of the super pairs that you can find is xy, yx. Yes, they are dependent on each other. If you had to write them all out, wouldn't there be 5 in total? Uh, technically, yes. Technically, there's only 5, like, and this kind of spoils into the other one, but however, one of these super pairs is an illusion. It's technically an illusion because one of them is forced into the relation. Can you guess which one? Right, one of these super pairs is kind of forced to be present at all times in your symmetrical relation. Can you guess which super pair here of the 6 super pairs who here must be present? It's this guy. This one, this is an illusion. Technic technically speaking, technically speaking, he's always present at all times. At all times, because we need x comma y, and our relation needs to be symmetric. So he's always there. So while we have 6 super pairs, how many are technically present? Only 5 of them. Yeah. That's where the 5 comes from. That's why we go down to 5. Why is XY always present? Because we want it to be. No worries. It's okay. You're not dumb. I promise. It's just nature of the beast. Nature of the beast. But hopefully that makes more sense on how I got the quote super pairs. Will I be in the atrium tomorrow? Yes. Yeah, I should be in the atrium tomorrow. I have a lab anyways to I have run. Will you be with us at the exam? Do I have to? Do I have to? Yeah, of course. No? Okay. I don't have to, I guess. Um I'll see if I can attend both of the final exams, whether it's either section, whether you're in the 4:30 class or the 1:30 class, I'll do my best to attend and guide you. Though when I get into that final exam, I'm pretty much just a gargoyle, just watching over you guys like a hawk. So apologies in advance, but I'll be there. I do. I'm not a. Don't come. Okay. You issue chat GPT. I think that was a little. It's okay. You're fine. Fine. We'll see. We'll see if I decide to come. Well, on the final exam, all the way through relations, I want to say I want to say also most likely he's also including probability. Yeah, I want to say probability is also included. So yeah, I should also make some questions on that. Yeah, and also you also kind of need all the other stuff. So like for example, you're going to kind of need um that after W there won't be anything. Was well, I assume the last thing he talked about today was like graphs and stuff like that. I'm assuming he talked about probabilities before today, though. Like that's what I'm assuming he talked about. Yeah, so like if the last thing he talked about was graphs, then yeah, probability is still on the chopping block. Nope, still hasn't told me about it. If he made it, he's being very secretive about it. Mm. Only one way to find out. Only one way to find out. But the reason why he says that you still need stuff from the previous exam, well, there were questions I give on this final exam practice is that uses process when first seen it. Most likely we're gonna make two different versions. So like even if you add to them what they made, what your exam was, like it doesn't matter because we'll make different questions. Yes, it's in class. Mhm. How do we determine the number of symmetrical relations? My hint to you guys is so I want you to draw a 4x4 grid, similar to what I have right here. So kind of like draw a 4x4 grid that has WXYZ on the columns and then also WXYZ on the rows. And what I want you to do is simply put, there are coordinates that have identical values, meaning the x and y coordinate have the same, or are literally the same. And what I want you to do is wherever that's possible, put a check mark. So here, this is WW. So we throw a check mark on there. And then we do the same thing throughout. And then for everyone else, for all the other coordinates, I want you to take whatever coordinate you land on, then invert it. And then I want you to locate the inverted point on the grid and draw a by implication arrow between the points. So as an example, you have WX, his inversion is XW, so we draw a by implication arrow going between the two of them. And I just want you to count how many check marks you have. Count how many check marks you make. Count how many by implication arrows you draw. Oh, so far so good on that. Now what I want you to do at that point is count how many ways you can insert all these symbols into a set. So do it for the check marks first. So that's pretty easy. Then do it for the by implication symbols. Makes sense? Are there any equations for determining symmetrical relations? Off the top of my head, I think there is. I think so. I think, can't remember. I think the equation, hmm, I'm not sure about this. I'll have to double check, but off the top of my head, I think it's n times n plus. Is it? I'm trying to think. What out of this? I want to say it's this. I literally want to say it's bad, but I'm literally not sure. I literally have not derived the equation in a long time, so like I'm sure about this, but I'm like 90% sure. I'm like 99, I'm 90% sure. Mm, and where n is the number of elements in your original set. In this case, A. I want to say that's what it is off the top of my head. But again, don't take my word for that. That's literally like so sketch. But yeah, that's off the top of my head. Um, any other questions you guys have for me? And that's pretty much all I have for today. I think so. I I think it's pretty valid. Mhm. Yeah, no problem. But yeah, that's pretty much all I have. Yeah, I'll try to have more study sessions throughout the week, Carlos, and I'll see what I can do. I'll upload this one to YouTube as soon as I'm done with the session, and then I'll let you guys know. Yeah, but that's all I've got. Let me know if you guys have any other questions, and I will see you guys on the next one. And guys.